Hello everyone, Jeff with the Green Review here. Today we are comparing the monocot trunk to the dicot trunk. Most monocots and dicots have small herbaceous stems, but today we're talking about the larger woody trunks. Monocots are characterized by having one seed leaf or cotyledon, the flower parts in multiples of threes, the leaf veins running lengthwise nearly parallel to each other. The monocot vascular system is comprised of scattered bundles of tubes. Dicots have two seed leaves or cotyledons. The flower parts are typically in multiples of fours or fives, and the leaf veins have a network design. The vascular tissue is produced in a ring-like pattern that permits annual growth rings, allowing the stem to grow in diameter. Common monocots include amaryllis, cannas, daffodils, grasses, hostas, irises, lilies, onions, orchids, palms, tulips, and others. Dicots include all the other angiosperm plants. Most monocots are herbaceous and do not have long-lasting woody trunks. The exceptions include bamboo and palms. Palm trunks are very diverse in size and appearance, but on the inside they're very similar. The growth point on the ends of the trunk in both monocots and dicots is the apical meristem tissue. The growing point on the palm tree is often called the bud or heart. All new palm leaves develop from this apical meristem heart. Palms may be single-stemmed or multi-stemmed as a result of branching from axillary buds low on the stem, but very few palms have aerial branching. If you eat a palm heart, you've killed that stem in the multi-trunk species or killed the entire palm in a single trunk species. Let's look at this piece of Alexander palm. These palms grow about 20 feet high. A single leaf can be about 8 feet long and have a 1-foot petiole. That's this stem part here. This is the crown shaft section of the tree. The crown shaft is created by the base of the leaves forming a sheath at the top of the trunk surrounding the apical meristem bud where all the subsequent leaves are formed. The crown shaft may look like a column sitting on top of the trunk. So the trunk was down here. The crown shaft is this section, which is made up of these leaf sheaths, which on a lot of times palms, these parts are called the boot. So as we break off this one, this part actually is a flower stem that's just starting to grow. So here's a palm boot. That's the sheath, that's the lower part of the palm leaf, and it will leave, when it falls off, it leaves these scars that you can see along the sides of the trunk. And here's another palm flower stalk starting to come off on this side. The flower stalks are at the they're produced by that apical meristem, and they are at the base of the apical meristem, where the apical meristem and the trunk meet, and they are protected by the leaf sheaths until the leaf falls off. So as we open this thing up, we can see here's the top of the palm trunk, here's the apical meristem, and then from here on up, all of the rest of this are the primordial leaf parts as they start to grow in the center. And as the older leaves fall off, the boots fall off, then the newer ones come out. And so this tree is as high as it's going to get. This area is going to, this apical meristem area is going to continue sending out leaves, and they're going to continue growing as the crown of the palm tree. Now this is the cross section of a royal palm crown shaft from about 40 feet up on a 55-foot tall royal palm. As you can see, there is nothing but the section of leaf petioles or boots. So when you're looking at the tree and you see that large section of the crown shaft, it looks like it's a solid piece of wood, for any lack of a better description, but it's actually just these leaf petioles. So one will go from here, the next one will go around to here, and then on the other side, and then it go around, and so they wrap around, and the entire section of that long crown shaft, several feet tall, is actually just these leaf sheaths, these boots that are wrapped around around each other at the top of the apical meristem where the trunk stops. Now let's look at this palm tree trunk cross section from about 6 feet up from the base of a 55-foot royal palm. So the center is drying out and it's coming apart here, but as you can see, the vascular system is scattered bundles across the whole area, all the way through the middle. The middle is called the central cylinder. The cortex is the area near the outside, and then there's the pseudobark on the outside, and this pseudobark has some lichens that give it some color and texture on the outside. The bundles are scattered all over across the trunk, but maybe more concentrated on a lot of palms near the outer edge. Some of the bundles are xylem and move water up and down, and some are phloem and they move the carbohydrates. In between the bundles are cells of undifferentiated parenchyma cells. Parenchyma. In between the bundles are cells called undifferentiated parenchyma cells. Lignin and cellulose are deposited next to the bundles for strength. The bundles run up and down the trunk like reinforcing rods in concrete, so they do a lot of the support of the trunk. The xylem and the phloem cells in palms stay alive for the life of the palm and can last many decades. Palms do not have lateral meristem tissue, but the dicots and conifers in the gymnosperm group do. Lateral meristem tissue is how the conifers and dicots trunks grow thicker over the life of the plant. The base of a palm tree is V-shaped. This trunk of the tiny palm gets thicker and thicker as new leaves are added. Then once the tree has achieved its maximum diameter, even though it's very short, the palm begins to grow taller while maintaining that same diameter it'll have for its whole life. You may ask, why does the base of a palm tree get so much thicker than the rest of the trunk? Roots on palm trees start at the outer region of the central cylinder where they connect with vascular bundles in the stem. As they grow, the sheer volume of new roots will force the cortex and the pseudobark to split and flare out from the base of the trunk. Now let's look at the oak tree cross-section. The cambium cells in this narrow ring are the lateral meristem cells that produce new xylem cells towards the middle and inside of the trunk, and new phloem cells toward the outside. Unlike the palm, the dicot, xylem, and phloem cells only live a year or two. The dead xylem cells allow water to move in the trunk, and then they eventually become the heartwood of the trunk. That's the darker color here in the middle. The phloem cells allow the movement of carbohydrates, and eventually they become the bark on the outside of the trunk. The lateral meristem cambium tissue can also produce new xylem and phloem tissue to cover up wounds. Palm trees do not have the lateral meristem tissue to cover up damage to the trunk, so wounds are permanent. So what's this mean to me? Monocot vascular bundles are scattered through the trunk and there is no lateral meristem tissue. So damage to the outer layer of a palm trunk does not cut off the flow of water and nutrients to the rest of the palm, but it will not heal. Dicot trunks can be killed by damage all the way around the trunk, and damage to the smaller area will heal. Another, what's this mean to me? Damaging the apical meristem at the top of a palm tree will kill the whole tree. Damage to the apical meristem on a dicot tree will release other lateral meristem buds from dormancy, and the plant will branch out and continue growing. The lateral meristem tissue in this cambium layer on a dicot trunk forms the rings that we can count to see how old the tree is. Palms don't have that, so there's no rings to count in a palm tree. You can't tell how old the palm tree is. But this small piece of wood here for this oak tree has, from the outer edge to the center, has more than 90 rings. So this is essentially around a 100-year-old piece of wood in the center of this. And finally, monocot trunks and stems will not change much in diameter, while dicot trunks and branches will continue increasing in diameter for the life of the plant. And this is Jeff with A Greener View. Thanks for watching.